The problem is find the center of mass of three particles at the vertices of an equilateral triangle. The masses of particles are 100 gram, 150 gram and 200 gram respectively. Each side of the equilateral triangle is 0.5 meter long. So here three masses are given. We have to arrange these masses at the three vertices of an equilateral triangle. The length of each side is 0.5 meter. Now I have to find the center of mass. Actually I have to find the center of mass of these three particles with respect to x-axis and with respect to the y-axis. So first we'll write given data that is m1 is equal to 100 gram, m2 is equal to 150 gram, m3 is equal to 200 gram. Now here this is m1, this is m1, this is m2, this is m3. So first we have to arrange at base, then we have to arrange at height. Okay, so m1, m2, m3, this is 100, 150, this is 200. The side, each side is along x-axis, the side is 0.5 meter. So for 50% this is 0.25 meter. This is. Now I have to find the particles like points, that is x1, y1 for mass 1 location, x2, y2 and x3, y3. We have to find the location of the masses m1, m2, m3 respectively. So if you consider m1 here, the location of m1 is x1, y1, x1 also 0, x2, y1 also 0. This gives 0, 0. Then x2, y2. That means at mass m2, the location of x2 is 0.5 meters and y is 0. Now x3, y3, the location is of the location of m3 is x3, y3. So I have to find x3. The x3 is, which is this distance far from origin. This is 0.25, 0.25. Then I have to find y3. The y3 will be the height of this triangle, equilateral triangle. Everybody knows the angle of equilateral triangle is 60 degrees. So we have to find tan theta here, tan theta. So for that, this is A, this is B. If you assume this is A and B, so I have to find AB. That means that represents y3 here. So find AB means tan theta is equal to opposite by adjacent. So opposite means AB by OB. So AB is equal to OB tan theta. OB means 0.25, tan theta means 60 degrees. That is 0.25 tan 60 degrees. That will be 0.25 into tan 60 means root 3. So the AB value, that means y3 will be equals to 0.25 25 into root 3. Now the formula xcm is equal to the center of mass of the particles with respect to x-axis, that is xcm is m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Now according to the given data, m1 is 100, x1 is 0, m2 is 150, x2 is 0.5 plus m3 is 200 into x3 is 0.25 divided by m1 plus m2 plus m3 means 100 plus 150 plus 200. Now solve this equation. It is xcm is equal to 100 into 0. This will be getting 0. 150 into 0.5 we can write 150 into 1 by 2 plus 200 into this can be written as 1 by 4 divided by 450 by adding these terms. This will be cancelled 75 times. This will be cancelled in 50 times. 75 plus 50 gives 125 in the numerator divided by 450. Now 25 in this number cancels 5 times. This will be 18 times. 450 divided by 25. So xcm is equal to 5 by 18, the center of masses. Then this is meters. Then ycm we have to find. The center of mass along y-axis, ycm is equal to m1y1 plus m2y2 plus m3y3 divided by m1 plus m2 plus m3. Now ycm, m1 means 100 into y1 means 0 plus m2 means 150 into y2 means 0 plus m3 means 200 into y3 means 0.25 root 3 divided by the total mass is 450 grams. So that is equal to, this will be 0, this will be 0, then we get 200 into root 3 by 4. 0.25 means by 4 whole divided by 450. 4 will be cancelled in this 50 times. 50 cancels here 9 times. So we get ycm is equal to root 3 by 9. This can be written as ycm is equal to root 3 by 3 into 3, that is equal to root 3 by 3 into, this 3 can be written as root 3 into root 3. So 1 root 3 and this root 3 gets cancelled. The final result is ycm is equal to 1 by 3 root 3 meters. This is the answer. So this question carries around 4 marks. So practice this very important question. Okay. Question is, find the torque of a force 7i plus 3j minus 5k about origin. The force acts on a particle whose position vector is i minus j plus k. So we have to find the torque. Torque we have to find. So the solution is, first we have to write given data. The given data is f bar is equal to 7i plus 3j minus 5k. This is the given data, and r bar is equal to, let r bar is equal to I minus j plus k. So we have to find the torque. Torque means tau. Tau is equal to r bar cross f bar. So I have to write a det here. That means r bar cross f bar is equal to the det of the data, that is I j k. First we have to write r values here, then we have to write f value, because r bar cross f bar. So this is 1i minus 1j minus plus 1k. So I have to write 1 minus 1, this is 1. Next, from force, the value is 7, 3 minus 5. I have to find the r bar cross f bar value, that is equal to I into a small det minus j into a small det plus k into a small det. From this we have to write, cancel these two terms, write these numbers in this small det, that is minus 1, 1, 3 minus 5. For j, cancel these terms, we have to write these two and these two, that is 1, 1, 7 minus 5, 1, 1, 7 minus 5. Now k, remove these terms, 1 minus 1, 7, 3. Now simplify these values, that is I into minus 1 into 5 minus 5, that will be plus 5, minus of 3 into 1 is 3, minus j, 1 into minus 5 gives minus 5, minus 7 into 1 gives 7, plus k into 1 into 3 is 3, minus of 7 into minus 1, that is minus 7. Then simplify this, we get I into 5 minus 3 means 2, minus j into minus 5 minus 7, that is minus 12, plus k into 3 minus of minus means plus, minus of minus means plus, gives 3 plus 7, which is 10. Now the final answer is 2i minus into minus plus 12j plus 10k. This is the final answer. This is r bar cross f bar. This the torque value is, okay, this is the final answer.